All right, last lesson, when we were learning about bivariate data, we learned about Pearson's correlation coefficient, which tells us how strong the relationship is between the two variables. If we get a coefficient of 1, it means we have a perfect increasing linear relationship between the two variables. But not everything's perfect, so we want to be able to calculate today the Pearson's correlation coefficient. Now, this is the formula. Remember, R is the letter we use for the coefficient, and it is the sum of each X score minus the average of X times by each Y score minus the average of Y over, we're squaring each of those and then square rooting. Now, to me, that's saying, all right, I'm getting rid of the sign on the bottom here. So the positive and negative part is going to come from the top. And then on the bottom, we're just using to make that fraction. It brings it down to a fraction that could be out of a maximum of 1. Positive or negative, though. If I was trying to find a line of best fit, we're used to using the rule y is equal to mx plus b. But we don't have to actually physically place a line on the graph to do what we're doing today. What we're going to be able to do is use the average of x and the average of y to calculate the gradient using these formulas that are here. So if you rearrange the formula, we could say that b would be equal to the average of the y values minus m times the average of the x values. That's basically here. We're saying average y, average x, but I'm just moving the mx across to get the b by itself. Okay? To find the m, we need to use this, which is very similar. It's just the gradient part coming from the Pearson's correlation coefficient. So they're our formulas that we're going to be using today. Classifying the correlation. The textbook uses the following as a guide for classifying. So we were just looking at things going, is that strong? Is that moderate? Is that weak? So this is how they classify if we can put a number on the correlation. So anything between 0.6 and 1 is a strong correlation. Between 0.4 and 0.6 is moderate. 0.1 and 0.4 is weak. And anything between 0 and 0.1 means there's virtually no relationship between the two variables. Okay, we are doing one question because it is quite involved. And we're going to do the same question again on the next exercise using our calculators to do it instead of the formulas. Okay, but this one we're doing it with the formula. So customers of a large technology company often ring about problems and are put on hold for short or long periods of time. At the end of the call, they are asked to rank the company from 1 being very dissatisfied to 5 being very satisfied. Some preliminary test data on the waiting time X minutes and the rank Y were taken with the following results. So basically they're saying that how long the customer waited, is there a relationship between that and how satisfied they were with the call, with the service that they got. So this is the information. So X is representing the amount of waiting time and Y is the rank out of 5 that the customer gave them. So to use the formulas, I'm going to need to find each of these things down here. The first thing I need is X minus the average of X. I don't know the average of X yet. I'm going to have to find that before I can put it in my table. So in the space down here below, to find the average of the X values, I'm going to have to add up all of those X's, which is already done for me. Here it is, 192. And I'm going to have to divide by the number of scores, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 192 divided by 12 is 16. So average of the X is 16. While we're at it, let's do the average of the Y's because we need that as well for this second row to fill it. Yes? By counting up how many scores I had. Yeah? So Average of the y, the total sum of the y is going to be 36. And there is also going to be 12 scores in the y data there. 36 divided by 12 means an average of 3. Okay, so lots of calculator stuff to happen now. To fill in this next row, we want to take each x score, which is 7, and we're subtracting 16. So 7 take away 16 is going to be -9. Then we do 15 take away 16, which is -1. 22, each one you're taking off 16. 22 take away 16 is 6. 11 take away 16 is -5. 20 take away 16 is 4. 15 take away 16, -1. 7 take away 16, -9. 28 take away 16 is 12. 6 take away 16 is -10. 16 take away 16 is 0. 26 take away 16 is 10. And 19 take away 16 is 3. If you add up all of those things, what do you get? Zero. Okay, that's why we're doing it. The average of each one away from their mean, and it should be 0. So it's going to happen for y as well. Let's go through. We're starting with 5. We're going to do 5 take away 3. We're taking off the y average. 5 take away 3 is 2. Then 2 take away 3 is -1. 2 take away 3 again, -1. 4 take away 3 is 1. 4 take away 3 is 1. 3 take away 3 is 0 for both those next two. 1 take away 3 is -2 for the next ones. 5 take away 3 is 2. 3 take away 3 is 0 and 0. And when we add all those up, it should also give us 0. Okay, it's the reason we find an average. It should be the same. Okay, so now, next one. X minus x bar, so that's this row. I just want to square it. It's getting rid of the sign value, saying how far away is each of those scores. We're going to square each one of these. So that will be 81, 1, 36, 25, 16, 1, 81, 144, 100, 0, 100, 9. Sum it all up. 594. Now go through and square all of your y minus average y. 2 squared is 4. Minus 1 squared is 1. 1, 1, 1, 0, 0, 4, 4, 4, 0, 0. And that adds to 20. Okay, now last row. We are multiplying these two rows together. So it's -9 times 2 would be -18. -1 times -1 makes a +1. 6 times -1 is -6. 5 times -5 times 1 is -5. 4 times 1 is 4. -1 times 0 is 0. 3 times, nope, sorry, look at the wrong one. -9 times 0 is 0. Oops, sorry, keep going. Keep going. 0. 12 times -2 is -24. Then 20, 0, 0, 0. All right, what does that make? -28? Excellent. Guys, can you concentrate, please? All right. We've filled in the whole table. The question down below here says to find the correlation coefficient and then the equation of the line of best fit. So there's two things we're trying to find. The correlation coefficient is the R, that formula there. Okay, so to find R, I need to sum the x minus x bar times y minus y bar, which is a number in my table. Which number is it? Just for the top of that fraction. -28. So R equals -28 over, on the bottom of the fraction, we need the square root of the sum of x minus x bar squared times sum of y minus y bar squared. They're two different things. I'll come back up here. This one here, what is the sum of x minus x bar all squared in your table? 594. And then the sum of y minus y bar squared is? So 594 and 20, correct. Good job. All right, so it's reading those things out of your table, putting them into your formula. When you do that, you can type that in the calculator now and get your correlation coefficient. You should get -0.26. Okay, so that's the first one. I found R. Now to find the equation of the line of best fit. To do that, I need to be able to I need to know a rise and run. I need to find my gradient, and then I need to be able to put it in my formula. Can we stop all the unnecessary chatter and just concentrate up here, please? Okay, using the formula at the top of your page for gradient, it said the sum of x minus x bar times y minus y bar, which is the -28 from the table. So it was the sum of this, which is the -28 down the end. Then you need to put that over the sum of x minus x bar. So here's your x minus x bar, which is 594 for the sum. Now that does not make a very nice number. I left it as a fraction. So -14 over 297. I found the gradient. I also need to find a y-intercept. There was a formula that we had, which was y bar minus mx bar. That's a short one. I'll write that one down for you. So y, the average y was 3. Right here. Y bar was 3. Then minus m, which I just found, was -14 over 297, times by the average of x, which is 16. 2 minuses in there become a plus, but you put it all in your calculator, and again, a horrible number, 1115 over 297. Almost feels like decimals would be better, but anyway. There it is. The equation of our line is what we're after. So using y equals mx plus b would be y equals, m was -14 over 297. So there's my mx, plus b, which is the 115 over 297. Okay, now that is a long and a little bit painful process, a lot of formulas to remember, and also big massive table to fill in. On the next exercise, it says using technology with bivariate data. It says it is far easier to use technology to find the correlation coefficient and the equation of the line of best fit. Okay, so it says there for smaller data sets we can use a calculator, providing that the calculator is capable, and our calculator is definitely capable. For larger data sets we would use a spreadsheet, but that is not at all something that I could give you on a test or the HSC exam, so that is not something that we're really going to need to practice. So this is the exact same question that we just did. Okay. Exact same table, exact same starting information. It says find the correlation coefficient and the equation of the line best fit, but this time using your calculator. So here is our lovely calculator. Let's go through the steps. First of all, make sure you go back to your home button so that you can see the statistics mode and click on the OK so that you're in there. We are going to be putting in 2 variables. So go down to 2 variable data and then you will see an X and a Y. I've got my frequency column on, but I can turn that off by going to Tools and going Frequency. I don't particularly want a frequency column for this. So there we go. All right, so has everyone got it looking like that? All right, now we're going to enter in our data. So the X is going to be the 7, 15, 22, reading that off your table. Press execute in between each one. All right, so once you've got them all in, then you use your arrows to go back up to the top and put in all your Y values. So 7 was 5, press execute and go down. All right, being careful to make sure I didn't miss any, because if you get a number wrong, unfortunately all your data that you get out of it is wrong. Okay, so has everyone got their data in? Now to get your data out of your calculate, press the execute button and it should bring up that menu. We need to go to the second one down, the regular results. And we are trying to make a linear line of best fit, which means we want an equation in the y equals a plus bx, because that's a straight line. There's a parabola and a log and exponential. We do not want those. We just want the top one, that's a straight line, and press execute. And there it is, it generates my information. So they don't use m and b, well, they do use b, but b is actually the gradient. Okay, so it says here y equals ax plus b. So my gradient is actually the b, which is the minus 0.04. Did I get the same results last time? Good, yep, just checking I did. Good. Type them in right. And the a is my y-intercept, and there is my correlation coefficient for r. And even though I had them as fractions last time, they are pretty much exactly the same thing as what we did when we did it with the formula. So back to our booklet. We're getting the correlation coefficient is negative 0.256, let's just go 69, that's more than enough decimal places. Our gradient, which is the b on the calculator, is negative 0.04714. And the b, which is the gradient, the y-intercept on the calculator, which is a, was 3.7542. Just reading those straight off your calculator screen, which means our equation of our line is y equals minus 0.04714x plus b, which is 3.7542. Probably keeping way too many decimal places there, but you get the idea? All right, I don't think we're going to do this again. So this would be the same question again, but then it says going using Microsoft Excel. I think we can save ourselves some time there and just stick with the stuff that we need to do. All right.